Okay. You want your hat? You
Starting right now.
Okay.
So go for it.
Good. What up?
I guess I'll just give it a few seconds to populate anything. Is my microphone on?
Yep.
Nice.
Potentially.
Do you want this off, or is this okay?
That should be fine.
Yeah, that's fine. Nope, it's not on. There we go. 1, 2, 3. Can you hear me? Can you hear me?
Yep.
Okay. Okay, so let's just go ahead and get started. Hey guys, it's Sam. I'm back. And you guys may have caught our last Facebook Live where we were out in Cape Coral at a canal. It's the Coral Pointe Canal, I believe. And we're grabbing some samples from there. Here's the sample in this bag. Because there was some really thick algae there. It was actually like hard. It was so thick we had to break through it. So some pretty gnarly stuff in here. And we collected the sample so we could bring it here to FGCU. We're at their Vester Field, correct? Vester Field Station, and they're a marine and environmental facility. So they're going to be able. Dr. Parsons here, you may recognize him. He's helped us out a lot before. Really appreciate him. He's going to let us know kind of what's in this, what he can tell just from seeing it underneath a microscope, and see if there's possible, toxins, what kind of algae it is, etc. So do you want to say anything just to introduce this?
Yeah, I think when I talked on the phone with you, you mentioned that the algae was a different color. It was looking more of a blue color. Yep. And then on the last Facebook Live story, I heard that you said it was even black or
yep.
brown in some areas. So to me, that either sounds like there might be a different kind of cyanobacteria in there, or that it's starting to degrade, which would mean it would go away. And the fact that it's really stinky would also indicate that it's probably degrading. So we can look at it under the microscope, see if there's live happy cells, or if they're dying and don't look so good. If it still is microcystis, which we've been dealing with for the most part, or if there are other algae in there.
Okay. So I don't know if you want to take a look at it, but I'm not sure how to give that to you.
Yeah, so one thing with the algae, I don't know if Kirk can see it at all, but it tends to float up on the top. And so a lot of these cyanobacteria have little gas bubbles inside them, and so that makes them float up near the surface. And so on one hand, that gives them an advantage because they're the first ones to get the light versus other algae and seagrasses. And then if they're blocking the light, that can be really dangerous for seagrasses because they won't get the light for photosynthesis. Mm-hmm. So a lot of times when you see that surface scum on the surface, it doesn't mean it's all through the water column. But still, if any people or animals are going to be exposed to it, it's probably going to be that really thick surface layer that's the biggest concern. Mm-hmm. And with all that biomass right at the surface, as it degrades, all those odors would get up in the air then, and then that's why you get that nice stench. And I think I'm getting it in my clothes now too.
Yeah, it smells really strong.
So I think the first thing to do would be in that green tray over there. I don't know if you see a little slide, or there's some little chamber slides.
This?
Maybe smaller, like.
Oh, like these.
Yeah, we can use one of those.
Okay, which one do you want?
The left-hand one. Here. So we won't be too scientific on this. We'll just pour some in here. We're just looking. We're not really quantifying. We're not trying to see how many algal cells there are per unit area. We're just trying to see if there is what it is in here. All right. So I need to get this in focus. Yeah, and you can definitely smell it.
And it pops up on the computer there. That's really cool.
Yeah, so you can see these kind of big clumps in here. I wonder if I can zoom even farther back.
Wow.
And so these are, it's really thick, so see if I can change the I don't know if it's going to let me do automatic or not. That's a little bit better. Yeah, so I don't know if you can really see it on the screen here, but where you see the brown spots in here, that would be dying cyanobacteria cells. There was something that was just swimming by, so there's going to be little microscopic animals in here and things like that too.
Me and Kurt kind of just looked at each other.
And so, yeah, this is a little, let me see if I can get this centered. So that's basically a colony, and then if you see all those little dots in there, those would be the individual cells. Mm-hmm. And so, you know, some of them are still green, the darker color ones, and you can see some are kind of a golden color, which again to me tells me that it's dying. It still looks like it's microcystis.
Can you
So that
explain
was the-
for those who don't know what that is? Can you explain what microcystis is?
So microcystis is a kind of blue-green algae or cyanobacteria. Let me increase the... that's a little bit better. That'll form these colonies that basically form almost like a ball, and then all the little cells are in it. And then they're all kind of connected together, so they're kind of sticking together. And so, let me go back to live here. Let's see. Looks like we might have a little storm coming, huh?
Yeah.
Let me reopen this. And so, let me zoom in a little bit more. So you can see each individual cell right in here. It's moving around a bit. And so there's, I don't know, there's like 10, 20, 30, 40, 50, and you know, on this side of the ball maybe. Mm-hmm. And so by the time you put it all together, you're probably looking at, you know, millions of cells all in this sample and things like that. And so microcystis, a lot of the strains of microcystis will produce microcystin, which is a toxin. Mm-hmm. This sample is stinky, we know that. And so what's happening is as that cyanobacteria biomass breaks down, the cells will basically lyse, they'll pop open, and they're going to release compounds. Some of them have a really like musty odor, and we're really sensitive to it. Some compounds are the same that are in skunk spray, and so you have some of that going on. And then there's hydrogen peroxide, which has a rotten egg smell, and then ammonia. So when you mix all that together, it gives that nice sewage smell that we are currently enjoying.
Yeah,
so
that's strong.
So I would say what we learned here is that we're still looking at microcystis. So the color change is not because of another cyanobacteria that was present in the sample. Mm-hmm. It looks like it's degrading, so the color change is related to the cells basically breaking up, releasing the compounds. Their color is changing as those compounds are either being oxidized or being broken down by bacteria. And then these really smelly compounds are being given off, and they'll basically volatilize, so they'll get up into the air, and then we breathe it in. All those compounds we're sensitive to, if you think about ammonia or rotten egg smell, and some compounds that most people don't realize we're really, really sensitive to would be these kind of musky flavor or musky odor compounds. So
Well, I think that, I mean, the smell is definitely unpleasant, and, you know, people might be sensitive to it, but the number one question this guy had, you know, the guy who led us into his backyard,
Right.
Was what does this mean, like, health-wise? Is it bad to breathe it in? Is it bad to touch it? That was his main question.
I would say don't touch it, you know, because when people are affected by the cyanobacteria, it's either through contact, so like dermal contact, like that. And so that can give some people rashes and things like that and get itchy. You know, I'll go wash this off in a little bit here, but I'm not too worried about it right now. So it's not like you have to call 911 or go right to the hospital or anything like that. But if you're swimming in it, if you're you know, kayaking or just getting water on you and you're at it for a couple hours, that might, you know, be the level of exposure that causes your body to react. And then otherwise, if you're in the water and you accidentally eat or drink some of this, which, you know, given its smell, people probably aren't going to do that, but dogs might. I know at least my dog would love this just because it smells perfect to her. And so I would be more worried about the your pets in this case. In terms of the odor, some people might be sensitive to hydrogen sulfide, the rotten egg smell. So if they have asthma, they might want to be a little bit careful because it could trigger an asthmatic event. The ammonia and the other smells, other chemicals, probably aren't going to be at high enough levels to really affect people. But again, if you're really close to it in the canal and you're breathing it, I could imagine you're going to get a headache and things like that. So,
I mean, is that because of just the smell and the sensitivity, or the toxins that are...
Not the toxins. Yeah, the toxins will not volatilize. They will not just evaporate into the air. When toxins get into the air, it's usually by a sea spray or small water droplets. So if they had a fountain out there, like a lot of these retention ponds have fountains, and if you feel the spray coming off of it and you breathe that in, you could breathe in the toxins then. But as long as there's no spray coming up off of the canal, they're not going to be breathing in any of the toxins.
Okay, so the toxins are not airborne.
Are not airborne by themselves. If there's very small water droplets, they can be.
Okay.
Yeah.
And then, what was my other question? So, yeah, you know, he was mostly just concerned about his health, breathing it in, the stenches in his house.
If he doesn't feel good, I mean, there's other compounds probably that we don't really know, and people might be sensitive to something. If he's getting big headaches, or any of his family members, or they feel nauseous. Did you feel nauseous last week or 2 weeks ago?
Because of the smell.
Yeah, you know, so maybe you were reacting to this, so it might not be any particular toxin, but a compound that's basically non-toxic, but your body is saying, I still don't like it, so it's letting your brain know.
Right.
Saying, brain, I don't like this, do something about it. So if he's getting headaches or doesn't feel well, he might want to go get a breath of fresh air somewhere.
Away from his house.
Yeah.
So, I mean, in terms of ingesting this, whether it's, you know, if someone catches a fish that might be in that canal and eat it, even though I highly doubt that that's a possibility.
I would not, yeah.
But ingesting any of that algae, what would that do?
If you ingest the algae, then you're introducing the toxin into your body and into your bloodstream. It will cause elevated levels of liver enzyme activity. It's a known liver toxin, and it can cause liver damage. So in acute doses, you could see some level of liver damage. You would have a similar response to food poisoning, so diarrhea, vomiting, nausea. If you have a compromised liver already, say alcoholism or hepatitis, it could cause real issues.
Wow. Well,
There have been a couple people we talked to who said they're still fishing in the river, they're still grabbing in the river. Mm-hmm. Any recommendations there?
I think you are elevating your risk of exposure would be one nice way of saying it, I guess. If you're fishing in an area where immediately the fish are at the bloom, they might be absorbing any toxins that are in the water through their body, through their gills, because they breathe in the water, so the toxins could be moving into their gills. If they're eating any shellfish or fish that eat algae, they would have the toxin, and then it would get into the bigger fish and then the people, so they could be exposed to toxin that way. The two primary ways of exposure for people are through food or through drinking the water directly. So that would just be another vector. So I would not recommend it, even if it was a nice, tasty fish.
Yeah,
So.
but I mean, that's only for the affected areas where the algae is visible, or is it like anywhere where the algae's moved through?
There may be lingering effects. We see that with red tide, where after the bloom leaves, you still might have the toxin in the shellfish and things like that. So the toxin might still be moving its way through the food web. We don't know enough about cyanobacteria toxins in that way. But these fish might be moving too. And so, but with this bloom, especially this degrading bloom, when it's degrading, that means the bacteria are breaking down all that organic matter. And in doing so, they're using oxygen to break that all up. So the oxygen levels are going to get really low in the water, especially at night, because there's nothing to produce the oxygen through photosynthesis. And the fish, they'll start feeling uncomfortable because there's not enough oxygen in the water. And if they can, they will move out of there as fast as they can. But they're almost holding their breath as they're trying to swim out of a canal where there's no oxygen. So because of that, they will try to avoid the areas. I know of no data or studies where there's any evidence of them avoiding a bloom because of toxins. So,
It'll be a smart fish.
yeah, but I think, south, downstream, I think, as long as you don't see any high numbers, discoloring levels of cyanobacteria, you can still fish. Upstream, if it's already flushed through, I haven't seen any of the recent numbers up at Franklin Lock or anything like that. I don't know if it's still coming downriver. I'd be a little more cautious there, just because there might be lingering effects of the toxin in the food web.
Gotcha. Well, in our story, we're going to talk a little bit more about how long we can expect. I mean, this stuff is dying, so we'll talk a little bit more about how long that might take, or like if there's anything we can do now to break it up or get rid of it, because a lot of people who live in that area were asking us that, like, how do we get rid of this? And I'm sure they're desperate to find a solution, so we'll talk a little bit about that, if that's possible or not. What was that?
No,
Do you have anything else that we can talk about in regards to the sample?
No, you didn't seem incredibly impressed by the beautiful cyanobacteria. But, we are seeing some, if you just look at it under the Petri dish here, you do see some of that bright green, bluish green color still. So there are still some living cells in here. So we may be seeing some die and others still growing. And so it may linger longer than just everything dying. And so, what we would do really is just kind of monitor it. And so the people that live in this canal, they might just want to see if the colors are changing, if they notice a change in the stench level, if they notice the change in the coverage of the algae. But it looks like it's dying, but I don't know if we can say it's 100% dying yet.
Gotcha.
It would take some more study on that.
Okay.
Should people do anything or try to do anything to remove it?
In the canal, I think it might go, it was pretty heavy. It had an iguana walking across it. So, there might be like a plankton net or a butterfly net or something like that, a really fine mesh net that might be able to scoop it up and out. Maybe a pool skimmer might be able to skim a lot of it out. That would help move the process forward, but just really depends on how much area there is. And that, I used to have a pool and I hated skimming my pool, so I think a canal is a lot bigger. So, but if they're desperate and want to do something, you know, it might be, but then you're going to be increasing your breathing, you're going
Yeah.
to increase your exposure to it.
Gotcha. Okay. Well, we'll talk a little bit more about that, and our story's going to air at 6, I believe, 6. So we'll talk a little bit more about, you know, solution-wise, what people can do. But for now, I guess, I don't know, we can give you one last overview of just like what we've been doing. We grabbed a sample from the canal, the Coral Pointe Canal in Cape Coral. So right here. We brought it to the Vesterfield station at in Bonita Springs, FGCU's Vesterfield station. Put it under a microscope with Dr. Parsons here. And we're going to talk a little bit more about it later. So thank you so much, Dr. Parsons, for participating in our
No
Facebook
problem.
Live. We really
Yeah.
appreciate your help. You help
Sure.
us out a lot. So we'll see you guys at 6. Thank you. Bye. Sit down. I hope